Yeah, good evening class. In the previous videos, we have seen what is time, speed and distance. Okay. What are the variants in this time, speed and distance, like problem on trains, where you can see distance cover related to speed, and moreover time related to speed comes into the picture, average speed comes into the picture. Apart from this problem on train, we have seen about there are other variants on time, speed, distance, like boats and streams, pipes and cisterns, clocks, races, etc. So in the previous video we have seen the first two shortcuts. One is a train crossing a pole or standing man or a tree. The second is a train crossing a platform, bridge or a tunnel. Okay. Today we are going to see the third one, which is the two trains are crossing each other, means in the opposite direction. Okay. See, if two trains are crossing into each other in opposite direction, we have to sum the length. Okay. We have to sum the length. So if it is crossing, so we have to sum the length of both the trains, that is taken as L1 L2. Thereafter, we have to add both the speed of the train. So when the relative speed comes into the picture, we have to take both the speeds S1 and S2. So the time taken formula comes like this, like L1 plus L2. This L1 is the speed of the first train, L2 is the speed of the second train. So we have to add these two and divide by the sum of the speeds, that is S1 plus S2. Okay. So now when we comes to the train crossing in the same direction, here the most important thing what you have to keep in the mind is that here the sum of the lengths L1 L2 has to be added. So the length of trains should be added, but the speed should be the difference of speed should be taken. One, the length is added. Second one is that the difference of the speed has to be taken, means that S1 minus S2 is taken into the picture. So the time taken is that as the is sum of the length, that is L1 L2, but the speed is getting the difference of speed should be taken. Okay. The third one is that the next one is that if the fastest train overtakes the slowest train in the same direction, here the fastest train overtakes the slowest train in the same direction. Here the distance is not given. Okay, the distance covered is not taken any vital role, but when we take the relative speed, we have to take the difference of speed, that is which, because they both are traveling in the same direction. So we have to take the relative speed as S1 minus S2. So here the time taken is that the distance covered as usual, it is L1 plus L2, but the relative speed has to be taken, it is S1 minus S2. Okay. The last before one is the train crossing a man in opposite direction. So here the man has no length. Okay, compared to train, man's length is much negligible, so that we can say length of the train is L. Okay, so here we have to sum both the speeds. One is speed of the train, another one is speed of the man. Okay, here so when the time comes into the picture, okay, when the time taken formula comes into the picture, that is length of the train divided by the speed of the train plus speed of the man, where the summation takes place because the man is crossing in the opposite direction, right? So the next one is, the last one is, the train crosses the man in the same direction. Here, as I already said, if the same direction comes into the picture, you can easily say it as it is length of the train, because the man has negligible length when compared to train, but here the speed of the trains is difference. So the difference means the speed of the train minus speed of the man, which because it comes into the same direction. Once it is taking in the opposite direction, we have to add it. If it comes to the same direction, so the negative comes into the picture. So speed of the train minus speed of the man. So that time taken is equal to L divided by speed of the train minus speed of the man, right? So here you can see, so to have a better understanding, we can see one basic problem. Here the train runs in the 72 kilometers per hour, crosses the pole in 18 seconds. So for the first thing what you keep it in mind is that here it is 18 seconds. So that you can see it is 72 kilometers per hour. 72 kilometers per hour. So first thing is that we have to convert this kilometer per hour into meter per second by multiplying by 5 by 18. So it comes under it comes as 20 meter per second, means that it is now we can say that 72 into 1000 for kilometer it is 1000 meters divided by hour is 1800, sorry. So it is 3600, right? It is 3600. So when we cancelling it out, it is out is 5, and in two tables it is 18. So it is come as 5 by 18. So it is now it is 72 kilometers. Sorry, it is 20 meter per second. So here the comes time the speed comes as 20 kilometers per second. So now it is train time. It is just already given. So it is length is 360 meter. Okay. So that's all for today. We'll see the next of the things in the upcoming videos. Thank you.